Okay, so for the third part of the MonoGame tutorials, which I think will be the last part, there's loads more we could go into, loads more, but this is really just a stepping stone before we move on to Unity. Um, in fact, on that topic, a lot of the stuff we're doing here, you would need to do in Unity, and that's why I'm showing you MonoGame, because stuff like the drawing of objects, that's handled by MonoGame, and you wouldn't have to code that. So I didn't want to jump straight to Unity and avoid showing you the frame loop, the rendering code, the game states, the loading of content, all that stuff that Unity does for you. This game would be super easy in Unity and quick. And that's kind of why we're doing it here first, to show you that there's a lot of stuff going on under the hood, give you a better understanding of the sort of concepts that are going on behind the scenes. Anyway, our game is about ready to be made, and we need to do collisions. So we've got a basket and there's falling eggs to catch with the basket. So we need collision boxes. Now, boxes come in different types. You can have the axis aligned bounding box, which is what we're going to use, AABB. And it's just a rectangle, in other words. But that rectangle is flat along the X and Y axis. So it's aligned to the axis. That's all that means. It's just a box, which means you can't rotate it. So if you want things that rotate, collision boxes that rotate, you need an oriented bounding box. And that's actually kind of complicated. We need to do some, well, it's not super complicated, but you need to do dot products and things like that. So it's a bit mathy. And it's not built into MonoGame. It is built into Unity. So there's another thing. You could do spherical collisions. You could do capsules, which is like a swept sphere. You could do cylinders. A lot of games have cylinders for 3D players. You could even do pixel perfect collision, but that can be a bit processor intensive if it's not handled correctly. So the one that's built in to MonoGame is the axis aligned bounding box, and in there it's called a rectangle. So we're going to build a rectangle around the basket and a rectangle around the edge. Now you could do it this way. Might not want to copy this right now, but during the gameplay we could, at the end, we could have a rectangle called basket collision box. Make that a new rectangle. So our basket collision box is a rectangle, so when you hit the dot operator, you'll see all the things that a rectangle has. It's got a bottom, a center, a height, left, right, x, y. The ones we're interested in to make a rectangle are the x, y, width, and height. So the x coordinate of the box is going to be the same as the x coordinate of our player's position, but that's a floating point, whereas rectangles use integers. We just cast it, it'll be fine. Same for the y coordinate. So our x and y coordinate of our rectangle is the x and y coordinate of the player. Now remember, that's the first pixel of the player's image, so that's the top left corner of our box. But that's fine, that's what the x and y defines. So then we need to get the basket collision box width, and that's going to be the same as the player's image's width. So the width of the basket is the width of our box, and of course the height of our basket is the same, sorry, the height of our box is the same as the height of our basket. And you could repeat that for the egg collision box if you wish, but that's quite a lot of code for one rectangle, and there is a slightly shorter way to do it. Instead of 5 lines, we can squeeze it into 3. So our rectangle basket collision box equals new rectangle, and we just, oh sorry, this is the constructor for the rectangle I should mention. So when you open that up, you can see there's 3 different ways to construct a rectangle. An empty one, 2 points for the 2 corners, or x, y, width, and height. That's what we're after. So put those 4 things in here instead. It's the exact same stuff I just put in, but one after another, right on the same piece of code. I prefer that. If you'd rather do it the other way, it's fine. It's exactly the same task it's doing, but I think that's slightly more compact and better for me to understand, at least. If you disagree, then by all means do it the other way. And now we need an egg collision box. and that will be based on the falling eggs position and width. Wait, did I put background position in there by accident? That should be player.position. But the other one, so this is all about the player, and this one's all about the falling egg. So now we've got two rectangles. But there's an even better way to do it, because they're very similar as well. That's repetition of code as well, even there. We could go back to our sprite class, oops, and put in a method that will give us a rectangle. So it's going to the return type will be rectangle, and we'll call that method hitbox. So we're going to return a new rectangle based on our position. Note I don't say player.position because we don't know if this sprite is a player or an egg or something else. We just know that it has a position. So even less code. And not player.image either, just image. So now every sprite has this hitbox method which will generate a rectangle for us. So we can just say, we could say basket collision box equals player.hitbox. And we could say egg collision box equals falling egg.hitbox. And that would work just fine. But you can simplify it even more, because all we're going to do is check for overlap between those two boxes. So we could just do it in one line like this. Take the player's hitbox method and check if it intersects with the falling eggs return value for the hitbox method. So if the hitbox for the player overlaps with the hitbox for the egg, then there's been a collision. So now that's our collision detection. Now we need to do our collision response. So what happens when there's a collision? Well, I guess first thing we do is give the player a point, add 1 to your score. And then we need to respawn the egg. So falling egg dot position equals new vector 2. Give it a random x coordinate and a negative y coordinate, so it's off the top of the screen. So it's probably good to put a sound effect in here. It'd probably be a good idea to refactor that, but you know, that's most basic, that will work. It might be nice to have some physics-based collision. Let's see, would that be too hard? Let's give it a go. In fact, you know what? I did this earlier, didn't I? Let's see. Let's have a look at the code for that. Save ourselves some time. Oh, you know, while I'm here, it's probably worth taking a look at the project that was created. So here's a session 7 project. And just like your text console based games, you've got a solution file which doesn't contain any code. You've got a folder with all your code in it. There's the program, and there's game 1. And there's the content folder with your MGCB file, plus all of your PNGs and waves and stuff like that. There's still a bin folder. If you look in the binaries folder, there's a Windows subfolder, the debug version of our game, and there's the actual executable. You can run it from here as well. Shut down, there we go. If somebody has .NET installed on their machine, which any reasonable new one will have, then you can just give them a copy of this whole folder and they'll be able to run your game. Here's the content, by the way. The reason you don't put .png on the end is, for almost all data types, except the songs, it converts them to this XNB format. Okay, so anyway, that's the layout of a MonoGame project on disk. let's look back at the code that I did previously for the collision. You know what, I'll just copy all that just now. I'll sort it out in a minute. Oh, sorry, instead of doing search, by the way, I did Control F and searched for hitbox, but actually a better way to do it, see if you right click on something, you can find all references to it, and then you can easily toggle between everywhere that word appears. That one appears twice on the same line, actually, that's why that's doing that. But yeah, collision detected. Let's replace the collision response. It's got something here called basket speed. That's how fast the player is moving. I'll just put it in for now. Oh, and I've already refactored spawn egg in that other example. But falling egg dot position equals new. Right, I think that'll do it. I'll explain that all in a second. Well, on detecting a collision, we then say, well, check the left edge of our hitbox for the player. So that'll be equal to your X, but we'll use left for reasons of clarity. So if the left-hand side of our basket has a coordinate that is greater than, in other words, to the right of the right-hand side of our egg. But we have to put in this -8 because that's how fast the player is moving. So if our left-hand edge of our basket is 8 pixels away from the right-hand side of our egg, then we could be moving into it. So therefore the egg gets pushed away. And the same thing on the other side, if the right-hand side of our basket is only 8 pixels away from the left-hand side of the egg, then we push the egg away to the other direction. Otherwise, if there's a collision and you're not touching it from the left or right-hand side, then we just continue the way we had before. We get a point, I respawn the egg. One small change though, I wanted the egg to fall into the basket. So I'm checking the bottom edge of the player's hitbox a second time. So this collision is going to keep on happening for several frames until eventually the bottom of the egg is close to the bottom of the player. So when it's fully fallen into the basket, that's when you get the point, not as soon as the thing touches you. Images, lives, but for now I think that'll do.